Welcome to part 6 in this series on chaos destruction. In this short video, we're going to be covering physical materials, or sometimes referred to as physics materials. These allow you to specify the physical properties such as friction, density, or restitution of a material, all of which can help improve the look of your simulation, such as making an object appear heavy or bouncy or slippery. Links to all relevant EPIC documentation will be in the description below. So, a very common question most people ask when working with chaos destruction is, how do I get my objects to look heavy? Well, that's where adding a physical material to your geometry collection can help out. In this scene, we have two boulders. Both are geometry collections that have been fractured. Let's run the simulation to see how they look. As you can see, they really don't feel like they are these massive, heavy boulders. I say feel like and not simulate like for a very specific reason. Unfortunately, as per EPIC, chaos destruction is not 100% physically accurate in its simulations. At least not yet. For example, it doesn't take air resistance into account, and gravity is applied the same to every object. So the best we can do is to tweak the settings in our physical material in order to get the look we want, or at least to fake the look, in order to get the simulation to be as realistic looking as possible. To do this often means using non-real world values, even though some of the physical material settings accept real world values. Let's create a physical material for the boulder on the right, so that when we run the simulation, it implies a sense of heaviness as compared to the boulder on the left, which will remain as our baseline default geometry collection. Open up your content drawer, and let's create a folder to store our physical material. Then right-click in your content drawer, scroll down to Physics, and select Physical Material. Select the physical material class, then click on Select. Let's call this PM_heavy boulder. Now double-click it to open it up. In this video, we'll be covering the 3 settings that EPIC recommends you adjust to affect the heaviness of an object. Those are friction, restitution, and density. Let's briefly talk about each one. Friction is the resistive force between surfaces that are in contact with each other while in motion. Static friction is the resistive force between surfaces that are in contact with each other just before they start to move. Restitution is the bounciness or elasticity of the collision between surfaces. Density is how much stuff or mass is packed into a given amount of space. Now, there are real-world values we could plug into these settings, for granite boulders in our case. But, as I mentioned earlier, regarding some of the shortcomings with chaos, you'll quickly find out that they really don't make much of a difference in your simulation. So, we're going to exaggerate these values to get the look we want. Let's start with setting a value of 100 for friction and static friction. This will help to eliminate a lot of the sliding between fractures and the ground. Next, let's set restitution super low to 0.000001. That's 5 zeros and a 1. Boulders don't bounce a lot, so we want to reduce any bouncing as much as possible. Then we have density. This doesn't have a tremendous impact in our case, but it can help to add a little tiny bit more heaviness to our simulation. A crazy value of 10,000 will do just fine. There's just one more thing we need to address before we test this out, and that is, how should the simulation interpret other surfaces we encounter especially if we don't know their physical material values. That's where the combine mode settings are really helpful. That's where we can tell the simulation how to interpret these interactions. Let's start with friction combine mode. Click on Override Friction Combine Mode to enable the drop-down settings. For our case, the higher the friction, the better. So select Max. So whichever surface has the highest friction value, the simulation will use that in its calculations. Next, click on Override Restitution Combine Mode to enable its drop-down settings. For this one, we want the surface value with the minimal amount of bounciness, so select Min. That's it. Click Save and close this window. Back in your scene, select the boulder on the right. In the Details panel, search for Phys Mat and add our new physical material to the Physical Material Override setting. While we're here, also enable Density from Physics Material. Now run the simulation and notice the difference in the boulder on the right as it simulates. It definitely looks and feels heavier than our default geometry collection on the left. So I encourage you to experiment with different values to see how it affects your simulation. For example, lowering the density can give you more fracturing of your boulder, if that's the look you're going for. And that concludes this tutorial on physical materials. If you found this video helpful, please hit that like button and subscribe to the channel. In part 7 of this series, we're going to take a look at some fracturing techniques you can employ to generate realistic-looking fractures. I hope to see you there.